Let's do some examples with the midpoint formula. There's quite a few examples, so bear with me. I might even recommend trying some of these problems out first and then watching the solution so that you get a sense of how you're doing and maybe where you're struggling. But either way, let's start with this. If the midpoint of RT is -1, 8. Okay, so we're given the midpoint. And R is at 5, -2. Find the coordinates of T. Okay, great. So let's think about this. The midpoint of RT. Now remember, the midpoint is has two parts, right? It has my X midpoint, or my X average, and my Y midpoint, or my Y average. And let's think about the midpoint of RT. It's made up of two different parts, right? The midpoint of RT, we have the X coordinate of R plus the X coordinate of T divided by 2. And we have the Y coordinate of R plus the Y coordinate of T divided by 2, right? And that creates my midpoint, those two pieces. So let's think, what do I have and what am I missing? Well, I have my X midpoint, right? I have my X midpoint. So I'm going to go ahead and write, I'm just going to do this. The X midpoint is -1. And I also have the Y midpoint at 8. I have the X coordinate of R, that is 5. I don't have the X coordinate of T. And I have the Y coordinate of R, which is -2. Oops. -2. But I don't have the Y coordinate of T. Okay, so how can I set up an equation that will let me solve for the X coordinate of T and the Y coordinate of T? Hopefully you're thinking in this direction. -1 is my X midpoint, so -1 is equal to 5 plus the X coordinate of T divided by 2. So then let's multiply both sides by 2. -2 is equal to, those cancel out, 5 plus xt. Subtract 5 from both sides, and we get -7 equal to the X coordinate of T. Sweet. And then now we're looking for YT, right? The Y coordinate of T. 8 equals -2 plus the Y coordinate of T divided by 2. Multiply both sides by 2. We get 16 equals, those cancel out, -2 plus the Y coordinate of T. Add 2 to both sides. And 18 is equal to the Y coordinate of T. So then the coordinate of T would be, T is -7, that's my X coordinate, comma 18, that's my Y coordinate. And that's the answer. And maybe something I want you to notice here, kind of think about it. The midpoint of RT is -1, 8. R is 5, -2. So this is kind of how I like to think about it. If I were to go from 5 to -1, I would need to go -6 on the X coordinate, right? I would need to move -6, a distance of 6 to the left, in order to find that. So since I moved from here to here, I moved -6. Well, in order to find t, I would just need to keep going that same distance, right? -6. So -1 plus -6, or -1 minus 6 is -7. And in the same way, for the y-coordinate, -2, to get from -2 to 8, I would need to add 10. So adding 10 gets me 8. Adding 10 again gets me 18. If that helps you, good, great. If it doesn't help you, just throw it out. You don't need it. But maybe that's a good way to start thinking about midpoints for you. All right, let's get into some more complicated problems. M is the midpoint of the line AB. Q is the midpoint of AM, and T is the midpoint of QM. The coordinate of A is 3x. The coordinate of A is 3x. Coordinate of B is 5y. Find the coordinates of Q and T. Okay, so let's go ahead and draw a line here. Beef it up a little bit. Maybe make it not dotted. Okay. So M is the midpoint of AB. I'm going to go ahead and start with A and B. So here's A. Here's B. And Q is the midpoint of AM. Oh, sorry. M is the midpoint of AB. So kind of in the middle. That looks about right. We'll call it. Doesn't have to be perfect. M is the midpoint of AB. Q is the midpoint of AM. And T is the midpoint of QM. The coordinate of A is 3x. The coordinate of B is 5y. Find the coordinates of Q and T. Okay, so we're going to try to find the coordinates of Q and T in terms of A and B. Now, when we talk about coordinates, this is just on a line, right? So you could think of it maybe as a number line, right? Like, oh, A is at 3 and then B is 5. And so in between here is something else, right? Our other numbers. That's probably the most helpful way to think of this, as this line is kind of like a number line, right? Because since we're only on a line, we only have one dimension. So the coordinate is only one number rather than a coordinate pair. Okay, I want the coordinates of Q and T. Coordinates of Q and T. So let's do what we can. Immediately, I can't find the coordinates of Q and T, but I can find the coordinates of M, because M is, right, the midpoint of A and B. So it's halfway in between those 2 points. So let's go ahead and say M is equal to A plus B divided by 2, right? A plus B divided by 2, because M is the midpoint. So that's 3x plus 5y divided by 2. And we could leave it like this as a fraction. I'm kind of okay with that. I think maybe it might be more helpful for us to go ahead and reduce here. So 3x divided by 2 is 1.5x. And 5y divided by 2 is 2.5y. You know, now that I've done that, I don't know if I love it, but we'll leave it like that for now. Okay, so that's M. M is 3x plus 5y divided by 2. And maybe in a second you'll see why I did this, but we'll just keep going for now. Okay, so now what can I find? What can I find the coordinates of? I can find the coordinates of q, right? So q is a plus m divided by 2. A plus m divided by 2. Okay, so that's 3x plus, and so then now you kind of maybe see why I did what I did and went ahead and divided there. So let's go ahead and use this part right here. 3x plus 1.5x plus 2.5y. That divided by 2. That's going to give me q. 3x plus 1.5x is 4.5x plus 2.5y divided by 2. And yeah, we can divide these without rounding. So, I'm okay with that. It's it's maybe not great, but we don't have to round. As long as you're not rounding when you divide your fractions, then I feel really good about that. If we had to start rounding, then I would just leave it as a fraction. Let's go ahead and go one more. So 4.5 divided by 2 is 2.25x. 2.5y divided by 2 is 1.25y. All right, well, we'll see how this treats us with t. So I don't know, maybe I should have left it like that, but whatever. We're doing what we can here. Okay, so yeah, so q is 2.25x plus 1.25y. And okay, so now we're solving for t, right? We're trying to figure out what t is. Well, t is the midpoint of qm, so that's q plus m divided by 2, which is 2.25x plus 1.25y plus 1.5x plus 2.5y, all of that divided by 2. Right, here's q, here's m. All right. Add them together. 3.75x plus 3.75y. Is that right? Yeah, that's kind of nice. Divided by 2. Which is... See, now things really start to get hairy. And this is where maybe I'm regretting my decision a little bit to simplify into fractions. So 3.75 divided by 2 is what? 1.875. I think that's right. Oh, you probably can't even see this right now, huh? Because my face is probably blocking that. Hopefully that's better. 1.875x plus 1.875y. Let me double check that real quick. 1.875. Great. Okay, so that worked out. So then that's your final answer. That's the coordinates of t. Oh, and I guess, also we had the coordinates of q right here. Yeah, I'm okay with that. I think on the next problem, we might get some more fractions and we won't reduce. And we'll kind of see how that feels and maybe what you like better. Okay, the last question. M is the midpoint of AB, X is the midpoint of MB, and R is the midpoint of AX. Let N equal RM and 2B equal MX. find AR, AM, RX, and XB in terms of N. Okay, first things first, let's draw out our line, right? That's going to be the easiest place to start. So, and notice that I like to make my lines nice and long. It helps me visualize things a little bit easier. So we have M is the midpoint of AB. So I know I have A and B on the ends, and then M is somewhere here in the middle. Okay, X is the midpoint of MB. So X is somewhere over here. And R is the midpoint of AX. Oh, that's kind of tricky. So maybe somewhere here. That's about right. Doesn't have to be perfect. Okay. Let N equal Rm. Okay, let N equal Rm. So this right here is N. And 2b equal mx. Okay. So mx is 2b. We want to find AR, AM, RX, and XB in terms of N. Okay, this is great. Yeah, this is really good because we can use what we know in order to, well, that's what we're going to do ultimately, is use what we know in order to find, in order to find all of these different lengths in terms of N. So what I'm thinking through right now is it going to be easier for us to say, well, let AB, the length AB, be something like X, and then we break down X into smaller parts? Or it might be easier to try to find our smallest part and then let that grow out. So we'll see. Let's just start in terms of B. Maybe that'll be helpful. Okay, so we know, because maybe if we get everything in terms of B, then we can get everything in terms of N and just go from there. Okay, so let's get all of my lengths in terms of B. Now we know that mx is 2b, and that x is the midpoint of MB. So then, what would this length, in terms of B, what would the length M be? What would that be equal to? Well, since mx is half of MB, then MB would be twice of mx, so that's 4b. Okay? And so then that would make AB, what would be the value, I guess, of AB in terms of B? Hopefully you're thinking that AB is equal to, I'm just going to write this, AB is equal to 8B, right? 8 B's make up that entire AB. All right, so now let's see if we can use that to figure out all of these other different pieces. Like what's AR? And yeah, and then we can maybe find RM. So since R is the midpoint of AX, right? So what's the length of AX? We have AX. What is the length of AX? Well, maybe we could say it this way. AX, that is equal to AB minus XB. Right? AX is equal to the whole minus the part. Minus XB. So XB, what is XB? XB is half of 4B, right? We found that out earlier. So XB is 2B. Little squiggly 2, that's okay. So AB is 8B, so that's 8B minus 2B, or 6B. So AX then is 6B. So then if AX is 6B and R is the midpoint of AX, then RX is 3B. Okay, that feels pretty good, because if we know RX is 3B, then what is RM? Okay, so RM, or maybe let's say it this way. RX is equal to RM plus MX. Since we know RX is 3B, so then 3B is equal to RM, which we don't know, we just know it's in, RM plus 2B, that's MX. Subtract 2B for both sides, and we get RM is equal to B. So, and RM was equal to N. So that means that B equals N. Okay, that's really great, because that should help us find out these points pretty easily. So, I'm kind of out of room here a little bit. We'll just do what we can. We'll do our best. Okay, we need to find AR, AM, RX, and XB. AR is half of AX. We know AX is 6B, so AR is, let's maybe see, I'm going to just use blue for all of these. So AR is equal to 6B, which was equal to 6N, right? Because B is equal to N. So AR is 3N. Okay, what about AM? AM, well, again, this is really nice. You could say AM is equal to AR plus RM. So AM is equal to 3N plus N, or 4N. Or you could say it's half of AB. AB is 8B, which is 8N. That's 4N. Okay, so we've got AR and AM. RX, well, like we said, RX is 3B. And 3B is equal to 3N. So RX is equal to 3N. And XB is this last bit right here. Like we said, that was 2B. So XB is equal to 2N. And that's our answer, right? That's all of those lengths in terms of n. Now, I know I said we might get to fractions on this one. Clearly, we didn't. But hopefully you can see that taking the individual pieces, I know that it's kind of a lot, right? This problem is really very involved. But we try to take those smaller pieces, make them bigger, and then make them smaller again, right? Take what we can, use what we know to figure out the big picture, and then use that big picture to zoom in again. That's the beauty of math, is that we can do so much with so little information. Okay, so this was all of our examples with midpoints. Hopefully that was helpful. And yeah, we'll see you in the next video.